Thank you everyone for joining today. So I'm going to be going through our chapter that I wrote with Dr. Tina Liu of University of California, Irvine. And we put together a chapter on active fire monitoring in the applications, the terrestrial application section of the book. So I'll give you some background about generally active fire monitoring and the data sets available in Earth Engine, and then go through the codes. Primarily this chapter is made of many apps and kind of getting to gain exposure to different data sets. So, okay, there we go. Okay, so we'll do our chapter overview, some theory, and then our practicum. And you can follow along on these slides. They're bit.ly link slides_A3.1. Okay, so our general overview, our goal for this chapter was to learn how to access, process, and explore fire monitoring data sets and apps to compare fires and fire seasons. So the learning outcomes that we prioritize were accessing and visualizing fire monitoring data sets in the JavaScript UI, to adjusting previously drafted code to calculate fire characteristics in the JavaScript UI for a fire of your choosing, to explore fire metrics and visualization using user apps, and to identify pros and cons of different fire data sets for a variety of fire monitoring objectives. So with this, we assumed that you know how to import images and image collections, filter and visualize. That's covered in the part F1 of the book. To write a function and map it over an image collection, that's chapter F4.0 of the book. To filter a feature collection to obtain a subset, chapter 5 and chapter 5.1, to design user interfaces for an Earth Engine app, that's covered in chapter F6.3, and to access and interact with previously made Earth Engine user apps, so that's F6.3. Okay, so going into the theory, for your knowledge, my background, I'm a forest fire scientist with the Canadian Forest Service, so using Earth observations for tracking fires. I primarily work in the active fire realm, and we use satellites, especially in a country as big as Canada, because we can have many different sources to give insights at a really large scale for how our fires are behaving. What you see here are a bunch of different options for of monitoring fires using satellite-derived data sources. This is for one example, the Elephant Hill Fire in British Columbia that happened in 2017. So you can see, we can make out the fire and its conditions in 10 different sources here. So you have Landsat 8, you can make it out, even though it's hazy, we can kind of see what the burned area especially. Sentinel-2, it's a partial coverage, but we can still make out the fire. Landsat 7 is striped, but it still provides valuable information. MODIS, of course, is coarser, so we can make out some actively burning parts, but it's still quite fuzzier really compared to the other sources. Planet data zoomed in, and folks could even start looking at different fire management decisions, like this flame retardant that was dropped to control the spread of this fire that's shown in the black burned area. GOES 16 and 17, which we'll go through today as well, is a meteorological geostationary satellite. So you can make out kind of in this way more of the clouds in this specific image. FIRS detects kind of fire intensity and biomass burning levels, so you can make out where the fire is hotter and burning more intensely. MODIS, this is another MODIS data set of burned areas that we'll also look at today in this chapter. You can see the progression of this specific fire from earlier in the fire season to later in the fire season. And then there's also vector-based data sets that do come from satellite data sources initially, but you can get the fire perimeters in this example. And then sometimes folks will go back and remove unburned regions and water bodies to be able to have a better estimate of burned area for carbon accounting. It's really important to understand the objective of what you're trying to do with fire monitoring, and also the objective of the data sources you're using, because the data set that you choose will depend on your objectives. So we've broken up, basically, we've created this conceptual framework to just kind of guide sorting these objectives and data needs into 3 stages of fire monitoring. So stage 1 is pre-fire inventory prior to when a fire breaks out. It's kind of looking at what's on the landscape, what can burn. Stage 1A, fire prediction analyses. Often the data from stage 1 is used in modeling and other predictive analyses. And stage 2, this is right when the fire breaks out. This is active fire monitoring. These are those near real-time data sets that tell you where's the fire and what it's doing. Then after the fire's extinguished or burns out, we can do impact assessments in stage 2A. And then in stage 3, there's post-fire assessments. A bit more time has passed, and there's more what's the burned area, what infrastructure was impacted. And then there's recovery dynamics that feeds into the pre-fire inventory again of how did the landscape regrow or rebound from fires. In the center, there are such studies that look at longer term and larger area analyses that we lumped into multi-scale synthesis. So how we've used this framework before is to basically categorize the objectives of all of the different data sources that are available in the data catalog in Earth Engine. And it's a really useful way to understand what you could use these different data sources for when it comes to fire monitoring. So you can go to this link up here if you want to look up yourself, or just search fire really in the data catalog. So for example, you can see for a post-fire analysis, I'll do orange for that, and then gray is the multi-scale synthesis, and then the red is for that active fire. So fire CCI is really a retrospective burned area analysis. So this is most useful for post-fire analyses. You wouldn't use it when during active fire stage because it just wouldn't have been updated for it. However, something like FIRMS is available for near real-time active fire monitoring, so this would be your go-to source for when a fire is actively burning. There's other fire boundaries from Globe Fire. Those are useful for post-fire analyses. And then in the USA, we have these fire regime data sources from Landfire, and that's more of a multi-scale analysis, multi-scale synthesis, because it brings in a lot of different information to derive that. Similarly, fire return from Landfire also falls into that category. Burn severity is a post-fire analysis because it takes a bit of time to really have high-quality observations to construct those data sources. So this is post-fire. Succession is also a post-fire analysis. Ecological conditions really come into these pre-fire inventory side, so vegetation condition class, vegetation departure, biophysical settings, and so on from Landfire is a really good source for that for the US. Ecological conditions also fall into that pre-fire inventory. And then those global burned areas from MODIS, this is another post-fire data set. Getting into more active fire options, there are all of the different MODIS thermal anomalies from Terra and also from Aqua. And sometimes they're in 8-day composites, but you can get kind of this active fire data set. Then there's also GOES-16 that has a fire hotspot characterization. And more GOES data sets primarily for North America and South America, or just the United States. So GOES-16 and 17, different kind of full disk is for all of the Americas, and then CONUS is just North America really, and primarily just US. And so you can go through with each of those. Then lastly, we have the VIIRS thermal anomalies, which this is a pretty newer data set added. Previously, it wasn't available in the data catalog. And then the burn severity for monitoring trends of burn severity, the burn severity images and the burned area boundaries, really great resources for the USA. Other sources you can have for fire monitoring are also available in the awesome GEE community catalog. This is the direct link if you want to go to the repository. And each one, there's so many different data sources in here, you should really check it out. But when I search just for fire-related data set, there's things like the Global Fire Atlas, near real-time firms, global VIIRS and MODIS vector dataset, which I don't think they have anymore because now the data catalog, the official one, has uploaded them. Different land fire mosaics, monitoring trends in burn severity before it was uploaded officially, some Canadian data sources, and so on. So some really great resources for fire-specific data sources. Okay, so now that you have some context for different types of fire monitoring and also specifically the data sources that are available in Earth Engine, be sure to now add the repository for the book if you haven't already. So you can go to this link, you can type it in, or if you go to the slides, you can click it and then refresh it because it will show up. So then you'll see under the A3 terrestrial applications, go to the active fire monitoring folder, and there's 4 checkpoints that will have either direct code or links to user apps that you can go to. Okay, so I'll give maybe a minute to do that before I think we go on to the practicum.